Hello and welcome to T3 Day 5 of Honors Precalculus. Today we're going to talk about hyperbolas, which look just like this, the red right here. And what's going to happen is they have two foci, just like we've had before in our other conic sections. And this distance right here, the absolute value of that distance is going to be a set number. So they're either going to go side to side or up and down. And the equations look just like this. Either you have x first, so x minus h squared, and then y minus k, or you have y first. And if you have y first, it goes up and down, and if you have x first, it goes side to side. The key thing to realize is you have to have minus signs in between. The center is still in the center here. The vertices of these hyperbolas, they touch the side of this auxiliary box is what they're called. The a value goes side to side, the b goes up and down. So it goes A, B, and B like that. It's pretty nice, and we just follow the formula. Then if we want to find the foci, the key thing is the foci are c units away from the center, where c is equal to a squared plus b squared. Hyperbolas are asymptotic. That means they follow and get close to asymptotes, and those asymptotes go through the corners of these boxes. So this asymptote is right there, and this asymptote is going to be right here, meaning the hyperbolas get infinitely close to, they don't touch it, but they get infinitely close to those lines right there. And the auxiliary rectangle is that box in the center. So if we were to graph one of these and it's already in the proper form, it's actually pretty nice because it tells us the center. In this case, the center is going to be 2 comma negative 1. So that's going to be right here. And then you know a is the square root of 4, so that's 2, and b is equal to the square root of 9, which is 3. So you go over 2 and up 3, back 2 and up 3. So you have this auxiliary box right here. This box right here tells us a lot of really great stuff. And since we know that x is first here, it's going to go left and right. So what we then do is we can put the vertices of our hyperbola right here. So we know the vertice for this hyperbola is going to be right here, and the other vertice is going to be right there. So if we wanted the asymptotes are going to be these lines right there going through the corner from the center. So I'll make it a little thinner. So it goes up like this, and it goes down like that, and then this one goes like this, and then this one goes like this. Now we can use slope-intercept form. That slope right there is equal to 3 over 2, and this one right here is equal to negative 3 over 2. So we'll call this one line 1, and we'll call this one line 2. Line 1, that's going to be y is equal to 3 halves x minus 4, because that's the intercept down here. And then line 2 is going to be y is equal to negative 3 halves x plus 2. Now, what we can do is we can actually draw a decent sketch of this if we wanted to, which we do. The decent sketch starts here, and it goes up like that, and then it goes down like this, and it goes up like this, and it goes down like that. So there's your sketch right there. Let's find the foci. The foci are those points inside each of these hyperbolas on the left and right. So we know that c squared is equal to a squared plus b squared, and a is 2 and b is 3, so c squared is going to be 4 plus 9, which is 13, so c is equal to the square root of 13. Now that's not a nice integer, so you just have to estimate a little bit. So that first foci is going to be right about here, because this distance approximates square root of 13, 3 squared, 4 squared, that's from the center, sorry, it's from the center, not from there. So from here to here, a little bit more than 4. So that point right there is going to be 2 plus the square root of 13 comma negative 1. And then we go back the other direction. We go back 4, a little bit more than 4. So it's going to be right about here. So we know that this distance right here is also going to be that c value. So that's going to be 2 minus the square root of 13 comma negative 1. Now, what are the intercepts here? Where does it cross the y-axis? Well, looking at this picture here, the only place it crosses the y-axis is going to be right there. So there's your y-intercept right there. Your y-intercept is going to be y is equal to negative 1. So you can write it as 0, negative 1. Now, your x-intercept is when y is 0. There's 2 of those, and those are not quite as integer-based. Those are up there. So the x-intercept is when y is 0. And what you do there is you just plug in y0 here. So you're going to end up with x minus 2 squared over 4 minus y plus 1 squared over 9 is equal to 0. And what you're going to do there is you're going to take this y equals 0 right here, and you're going to plug it in right there. So you plug in y equals 0 right there, and you're going to then get x minus 2 squared over 4 plus 1/9 is equal, sorry, minus 1/9, that's important. Minus 1/9 is equal to 1 right there. So then what you end up with is x minus 2, let's multiply, squared over 4 is equal to 10 over 9. Multiply by 4 on both sides, you end up with x minus 2 squared is equal to 40 over 9. So x minus 2 is equal to plus or minus the square root of 40 over 9. So we end up with x is equal to 2 plus or minus the square root of 40 over 9. So your two x-intercepts, those are these 2 points right there and right there. Those two x-intercepts are going to be, they're going to be, 2 plus the square root of 40 over 3, which is the square root of 9, comma 0, and 2 minus the square root of 40 over 3, comma 0. Those are your two intercepts. So the only change right here is that we're going to have to put this into our standard form first. So let's factor out the 4 from the y term, and you get 4 times y squared minus 2y plus something. And then you also going to factor out a negative 16, you get x squared plus 2, negative, so 2x, because it's negative. And then that's going to equal 76. So what are we going to add here? Well, we're going to add negative 2 over 2 squared, so we're just going to add 1. But if we add 1 here, we have the 4 on the outside, so we have to add 4. And then over here, in this blue space right here, we're going to need to add 1 again, 2 over 2 squared, but it's negative 16, so we're going to have to do minus 16. So when we do this out, we end up with 4 times y minus 1 squared minus 16 times x plus 1 squared is equal to 64. Hey, nice square number. So you divide by 64 and you end up with y plus 1 squared over 16 minus x plus 1 squared over 4 is equal to 1. What's nice about this is it tells us immediately that the center is going to be negative 1 comma negative 1. So the center is right here, and we know that this is going to go up and down because y is first here. You see how y is first in the minus? And then what that means is we're going to go, we know that a is equal to 2 and b is equal to 4. So we go down 4, since it's going up and down, we know the vertice is going to be there, we know the vertice is going to be there, and it's going to go over 2. It's going to go over 2. So we could draw these vertices if we wanted to. So we know that the vertices themselves are going to be here and here because it's going up and down. And we know these asymptotes look like this. So here's our asymptotes. I'll draw this really nicely, like this, like that. And then, therefore, we know that this hyperbola is going to look just like this. It goes up, and it goes up like this. So the asymptotes are just these lines right here. And if you use slope-intercept, you can find that that's 2x plus 1. And then this one's right here is going to be y is equal to negative 2x minus 3. And you can do that straight from the intercepts that you see right there. So what about the foci right here? How do you find the foci right here? Well, you know that c squared is equal to a squared plus b squared. So therefore, c squared, where's our a? A is going to be equal to 2, and b is equal to 4. So this is 20, so c is equal to the square root of 20. So what that means is you go down from the center, you go down the square root of 20, 3 squared is 9, 4 squared is 16, so it's like 4 and something, so it's right about here. So it goes to here. So there's your first foci right there. So our first one, our first foci, right, so it's going to be negative 1, and then it's going to be negative 1 minus the square root of 20 right there. And then this foci right here is going to be negative 1 plus the square root of 20 right there. Now let's take a look at these. Are there any x-intercepts? There are no x-intercepts. There are no x-intercepts. Now what about the y-intercept? Well, it looks like there's going to be 2 of them. There's 2 y-intercepts, and those are going to be right here and right down here. So if we do the y-intercepts out, you're doing x is equal to 0. So you plug in x is equal to 0 into our standard form, which will make it easier to do the algebra. And when you do that, you end up with y plus 1 squared plus, minus, I gotta do the minus, don't forget that. When you plug in 0, you get a fourth is equal to 1. So you get y plus 1, and this is over, 16, squared over 16 is equal to 5 over 4. So you end up with y plus 1 squared, you multiply by 16 on both sides. That simplifies to 20. So you end up with y is equal to -1 plus or minus the square root of 20. So that means that the two y-intercepts right there, the two y-intercepts are going to be 0, comma, -1 plus the square root of 20. So go up because you start at -1 right here, and then you get 0, and then you have -1 minus the square root of 20. So it's a lot of mechanical repetition, but it's pretty cool that you can get something that smooth from this. And remember that the eccentricity can also be defined here, and it's down here right there. Eccentricity is equal to c over the semi-transversal axis, and the diagram for that is above.